This program is provided by Universal Genesis.
Welcome to our deep dive. Today we're asking something a bit, counterintuitive. Can we look at Aristotle's unmoved mover? You know, this huge concept, often tied up with theology.
Yeah.
Can we strip all that away and see maybe a physics equation hiding underneath?
That's a really productive way to frame it, I think. Our sources suggest it's not just possible, it's maybe even necessary to understand what he was really getting at.
Right.
And what's fascinating, really, is we're not trying to shoehorn Aristotle into modern science. It's more like recognizing he was tackling a fundamental structural problem.
A problem physics later found a mathematical language for.
Exactly. He was trying to describe something about the very nature of change and stability.
Okay, so the core idea for you listening, the analogy we're really digging into, is this. Could Aristotle's to Purton Knudsen, the first unmoved mover, be the ancient philosophical version of something like 5 Medor or, a UMC2 talk?
That's the comparison.
And our mission here is to take his whole system, natural science, maths, metaphysics, and read it again. Read it as this unified search for lasting principles.
Structural principles, yeah.
Trying to, in a way, free him from how history, especially theology, kind of boxed him in.
We're essentially trying to reclaim Aristotle, the theoretical integrator. He was fundamentally looking for what doesn't change in a universe that's all about change and motion.
Invariance.
Invariance, exactly. And the moment you start looking for that, instead of, say, God in the later sense, the concept just clicks into place differently.
Okay, let's start there then. The unmoved mover. Why did he even need it? What was the logical pressure? It really boils down to that problem of infinite regress, doesn't it?
It does, absolutely.
Yeah.
So Aristotle looked at the world and saw constant motion, constant change. And he reasoned, okay, everything that moves must be caused to move by something else.
Like dominoes, one hits the next, which hits the next.
Precisely. But, and this is the crucial bit, that chain of causes can't just go back infinitely.
Why not? What's the problem with infinite causes?
Well, if the chain is infinite, there's no first mover to get things going, or maybe more accurately, to sustain the movement now. Nothing would ever actually be moving in the present if the cause was always deferred infinitely backwards.
Okay. So you need something that's the source of motion, but isn't itself moved by anything prior.
Exactly. Something that moves others, but is itself unmoved. It wasn't necessarily about a creation event, like a first push. It was a logical requirement.
A requirement for motion to even be coherent, to exist right now.
Right, for the establishment and, importantly, the continuation of movement.
Okay, that's the key pivot, I think. It's not about the first thing in time chronologically. It's about the first thing in the logical order, the underlying principle.
That's a much better way to think about it.
But here's the jump. How does that logical need for an ultimate unmoved cause translate into something like a mathematical equation? That seems like a big leap.
Well, think about the definition again.
Yeah.
What does an unmoved mover need to be?
Yeah.
It has to be permanent, unchanging, a fixed structure
Okay.
that somehow governs or enables change and motion and everything else.
Yeah.
Now, look at a fundamental equation like EMC2/2.
Right.
What's the unmoving part? Well, the formula itself is fixed. And c, the speed of light, is a fundamental constant. It doesn't change. It doesn't get moved.
Okay, the structure is constant.
Yes. But what does that equation do? It describes, it governs, it, dominates every single instance of mass turning into energy or energy into mass throughout the entire universe.
Huh. So it moves everything else, in a sense, by defining the rules.
It perfectly fits the description.
Yeah.
An unmoving principle that moves everything else by dictating the relationship between fundamental properties.
So the equation itself acts like the invariant structure that makes all the physical transformations possible and coherent. I really like that framing.
Mm-hmm.
It suggests that when physics, found its mathematical language centuries later, it didn't actually discard the need for an unmoved mover.
No, not at all.
It just gave it a symbol, a value, put it in an equation.
Precisely. Think about the scientific revolution. People like Newton, they consciously moved away from needing a sort of mechanical God figure winding up the cosmic clock.
Right, the divine watchmaker idea faded.
It did. But they didn't just leave a gap there. They immediately filled that metaphysical requirement, the need for some kind of unmoving foundation, with universal laws.
Laws expressed mathematically.
Yes, universal laws and invariance, expressed in the language of mathematics. That historical shift from Aristotle's logos-based approach to the mathematical approach of Galileo and Newton was the transition.
So Aristotle was basically articulating the structural need for something like a physical law, but he just didn't have the mathematical tools yet.
You could say that. He identified the logical shape of the solution, even without the specific notation. He saw the need for invariance underlying change.
Okay, this makes more sense if we put it in his own context. Let's unpack his system a bit. Where did this unmoved mover idea even live within his organization of knowledge? We need to understand metaphysics' place in his epistoma, his system of sciences.
Absolutely crucial, because his system wasn't just a list of subjects. It was structured, hierarchical. It mirrored a process of increasing generalization, moving from concrete particulars to abstract universals.
Can you walk us through that structure, specifically his theoretical sciences, the ones aimed purely at knowing truth?
Sure. So at the base level, the most concrete, you have natural science or physicae. This deals with the changing, moving material world. Think biology, physics as he knew it, meteorology, all the messy, tangible stuff.
Okay, the world we experience directly.
Right. Then, moving up a level in abstraction, you get mathematics. This studies abstract forms, quantities, shapes, things derived from the physical world but considered in themselves, apart from specific matter.
So less about this triangle, more about triangularity.
Exactly. More general patterns. And then right at the very top, the pinnacle of this theoretical structure, he placed metaphysics. He called it Proschli Philosophia, first philosophy.
First philosophy. And this wasn't just like random armchair speculation. It earned that top spot.
Definitely not random. Metaphysics for him was the science that studied being qua being existence itself in its most fundamental aspect. It sought the ultimate principles, the archo, underlying everything.
The common ground for all reality.
Yes. And its position at the top wasn't arbitrary. It was seen as the ultimate generalization. It's what you arrive at when natural science and mathematics mature, and you try to find the principles that unify them.
So his metaphysics wasn't trying to go beyond the other sciences into some mystical realm, but rather to integrate their findings, to find the common logical structure.
That's the key insight, I think. His goal was intellectual integration. He was searching for the unified principles common to all forms of knowing. You could almost see his metaphysics as a kind of prototype for grand unified theory and philosophy.
A philosophical GUT.
Yeah, something like that. Centuries before physicists had the tools, he was trying to map the logical framework that held his whole understanding of reality together.
Okay, but that brings us back to a critical point you touched on. If he was after this universal structure, this integration, why rely so heavily on philosophical language, on logos, arguments, and logic rather than math? Geometry existed, numbers existed. Why wasn't that his primary tool?
That's a great question. I think it's because the kind of structure he was primarily interested in, especially concerning the unmoved mover and purpose, was about meaning and logic, not just quantity or measurement.
Meaning? How so?
His worldview was deeply rooted in logos, which isn't just word, but also reason, structure, account, intelligibility. He saw the cosmos as an ordered, understandable system. He was asking what things are, their essence, their function, their place in the logical order.
Not just how much or how fast.
Exactly. Modern physics excels at the how much. Aristotle's tools, especially his powerful system of logic, the organon, were designed to analyze concepts, definitions, causes, and purposes, the qualitative structure of reality, the meaningful connections. He didn't have calculus, but he had arguably the most sophisticated system for conceptual analysis the world had seen.
So his language fit his questions about intelligible order.
It did. He was mapping the logic of being as he saw it.
Which brings us to the tragedy, as some sources put it. What happened when this really elegant, logic-focused system got picked up centuries later? Specifically thinking about the Middle Ages, Thomas Aquinas, the Scholastics. They integrated Aristotle into Christian theology. What was the cost?
The cost was pretty immense for his legacy as a natural philosopher. When Aquinas, brilliantly in many ways, synthesized Aristotle with Christian doctrine, Aristotle effectively became the philosopher, capital P.
Canonized, almost.
Yeah, almost, yeah. He became the sacred authority on matters of logic and nature. And the consequence was, it kind of froze him in time. It robbed him of the philosopher's essential right, the freedom to be wrong.
How so?
Well, his scientific ideas, some of which were incorrect based on limited observation, like the Earth being the center of the universe, the geocentric model, these became structurally tied into a larger theological framework. So challenging Aristotle's physics, even with new evidence later on, wasn't just a scientific debate. It felt like challenging the whole system, potentially challenging dogma.
So he became a tool for justification rather than a starting point for inquiry.
In many ways, yes. His dynamic, evolving thought got solidified into a static authority.
Okay. So if we want to rescue him, To see the genius of the structural thinker beneath the dogma, how do we rescue the unmoved mover concept specifically? How do we pull it out of that theological context?
We had to be really clear about separating the original logical function of the concept from its later theological interpretations. We need to firmly reread the first cause, as we discussed, not as the first event in time like a creator god setting things in motion,
Right.
but as the first in logical order, the foundational principle, the fixed law that allows the eternal movement of the cosmos to continue coherently.
Because Aristotle himself saw the universe as eternal, didn't he? No beginning.
Exactly. His cosmology was generally one of an eternal cyclical universe. The unmoved mover wasn't needed to start it. It was needed as the ongoing logical condition that enabled that eternal motion and prevented it from descending into chaos or paradox.
So we're shifting focus from a historical agent, a who, to a logical precondition, a what.
That's the essential rescue operation, conceptually. It puts the emphasis back on structure and necessity, which seems much closer to his original project. And it helps explain why he used philosophical language. He was outlining the preconditions for rational thought about motion itself.
He knew the shape of the answer, the necessary structure, even without the equations.
That's a good way to put it.
Now, if the unmoved mover is like the engine or the fundamental law, what about its, let's call it controversial twin, the final cause? Teleology, the idea that things move towards some inherent purpose or goal.
Ah, yes, teleology.
This one seems even harder to square with modern science. Why did early modern science, post-Galileo, Newton, reject it so strongly?
It got rejected primarily because it seemed, well, unscientific, mystical even. Asking, what is the purpose of this stone rolling downhill? This didn't seem like a useful scientific question anymore.
Right. It implies intention or desire in inanimate objects.
Exactly. So modern science, particularly physics, replaced that why question, the final cause, almost entirely with the how question, the efficient cause.
For push and pull, mechanical forces.
Yes. The world became seen as a giant mechanism, a clockwork, governed by prior events pushing subsequent events, action and reaction, no need for goals or purposes.
But looking at our sources for this dive, it seems the final cause isn't quite dead. It hasn't vanished. Maybe it just changed its clothes.
That's a really interesting way to see it. It definitely hasn't disappeared entirely. It's returned, but sort of stripped of conscious intent, reformulated in scientific, often quantitative terms.
How so? Where do we see echoes of it?
Well, think about modern biology. You have the concept of teleonomy. That's the idea that biological systems look incredibly purposeful.
Like a bird building a nest seems goal-directed, or DNA replication seems designed for self-preservation.
Precisely. These systems appear to be striving towards a goal. But teleonomy explains this apparent purposefulness as the result of past evolutionary processes, natural selection, operating blindly over millions of years.
So the goal isn't a future pole, but the result of a backward-looking filtering process.
Exactly. The appearance of purpose is explained by historical, mechanistic causes, not by an inherent future goal guiding the process now.
Okay, that's biology. What about physics or cosmology?
There too. We find concepts that imply some kind of inherent directionality or an optimal final state. Perhaps the most famous example is the principle of least action.
Ah, right. The idea that nature is efficient.
Kind of, yeah. The principle states that when something, like a particle or a light ray, moves between 2 points, it follows the path that minimizes a quantity called action. It often translates to the quickest path, or the path requiring the least energy expenditure, metaphorically speaking.
So it's almost like the universe is constantly optimizing, behaving as if it had a goal, the goal of minimizing action or energy?
It certainly looks that way. It's deeply embedded in our fundamental physics, from mechanics to quantum field theory. Systems tend toward states of minimum energy, maximum entropy. There's a directionality.
So today's science takes the core idea of the final cause directionality, an end state, but interprets it not as conscious purpose.
Definitely not conscious purpose.
But as system stability or order or optimization expressed through quantitative principles like energy minimization.
That's the transformation. Aristotle's final cause, which was about inherent purpose, has been largely reformulated into principles describing the directional tendencies, equilibrium states of physical systems. It's about directionality derived from the laws themselves.
Okay, let's try to bring this all together then. The main takeaway from this deep dive seems to be that Aristotle's whole project was fundamentally about finding change within invariance. He was looking for the stable structures, the principles that ground all the movement and becoming we see.
That's a great summary, the permanent within the flux.
And if we could, magically transport him to today, our reading suggests he might actually recognize his unmoved mover in an equation like AMT22.
The invariant structure governing change.
Yes, and you might see his final cause reflected, maybe transformed, in something like the principle of least action.
The inherent directionality toward stable states. It's plausible he'd see the conceptual lineage.
And if we're searching for the absolute peak modern parallel to his quest for movement within permanence, where do we land?
I think the most elegant and precise modern equivalent is found in the relationship between symmetry and conservation laws. This is beautifully captured by Noether's theorem in physics.
Explain that connection briefly.
Essentially, Noether's theorem shows that for every continuous symmetry in the fundamental laws of physics, there corresponds a conserved quantity. For example, if the laws of physics are the same everywhere in space, spatial symmetry, then momentum is conserved. If they're the same at all times, time symmetry, energy is conserved.
So the symmetries are the unchanging aspect.
They are the unmoved symmetries in the laws themselves.
And they generate the conservation laws that govern all physical interactions, the things that move the world.
Exactly. These symmetries and their resulting conservation laws are perhaps the most rigorous scientific expression of an unmoving principle that generates and governs all movement in reality. That's the unmoved mover, articulated in the language of modern physics.
Wow. Okay, one last thought then. It's striking that Aristotle's Metaphysics, the book itself, wasn't even a finished treatise. It was like compiled lecture notes, right? Unpolished thoughts, maybe.
That's right. It's often seen as a collection of working papers, explorations.
So it was never intended to be this absolute final dogma it later became. It was more like an open-ended exploration, a map of the frontier of knowledge as he saw it.
A work in progress, mapping fundamental questions.
So now that we've, in this deep dive, tried to rescue the unmoved mover from that historical theological box and return it conceptually to physics, to structure, what new questions does that raise for us? What does it mean philosophically if the ultimate foundation of reality isn't an agent, but an unchanging mathematical or logical structure? What is that structure that remains unmoved while generating everything?
That is the big question, isn't it? Does it point towards a kind of mathematical Platonism or something else entirely?
Something for you to definitely ponder long after we finish this dive.
This program is provided by Universal Genesis.